Hey guys, Mr. Falcucci here. Just want to finish going over this open response from earlier today that we got cut off with the end of class. So we got part A done right here. So let's take a look at part B. So it says if the machine requires no more than 3% of bottles to be overfilled, what should the mean fill amount be? So if we scroll up here, okay, we still know, right? So we don't know what the mean should be, right? So we're missing X bar. We don't know what the mean should be, or mu. What we should probably call it mu right here. So we're missing mu, all right? But we do know, right here, it says the standard deviation is known to be 0.15, right? And I want to know, okay, that no more than 3% of bottles should be overfilled. So what I can do, right, if I go over here, is I know that my mean, we don't know what our mean is, I should say. The standard deviation is 0.5, but I do know that I don't want any more than 3% of bottles overfilled. So I know if I draw the normal model right here, okay, that we still have our mean in the middle. We don't know what it is. All right, but I know that over here, that if I put a line over here, right, I want this area over here to be 0.03. So what I could do, right, is let's go ahead and find a z-score to go with that. All right, so we're going to go ahead and find a z-score here. Okay, if we think about this z-score as a standard normal model, I'm going to go into my distribution here, right? I'm going to use my distribution menu. I'm going to use inverse norm. If the area to the right is 0.03, I know this area over here to the left is 0.97. So I'm going to put that in for my area. And if I use a mean of 0 and a standard deviation of 1, that's going to give me my z-score as a standard normal model. All right. So just go ahead and hit paste right there and then hit enter. All right. And while I don't know specifically, what this value is as it relates, okay, to this problem, I do know that this value right here to have 0.03 above it would give me a z-score of 1.88. Right? And if we go back a couple slides here, so I'm going to get rid of the calculator. If we go back a couple slides, right, remember we have these two formulas right here. Either we're finding a z-score or an x value. All right, so to find an x value, right, we know that x equals z, okay, times the mean plus the standard deviation. Z times the standard deviation plus the mean. All right, so if we go back here, all right, so we want no more than 3% of bottles to be overfilled, okay? And we know that overfilled is 2.25 liters, right? 2.25 liters constitutes a bottle being overfilled, all right? So if we come back here now, so my x value, 2.25, is when that gets overfilled, okay? My z-score we just said is 1.88. I know my standard deviation is 0.15, but I don't know what the mean is right there. So what I could do here, all right, is we take out our calculator. We could simply do out 1.88 times 0.15. So I have 2.25. It's a little messy. Let me start over there. 2.25 is equal to 0.282 plus the mean. So then I could subtract that to both sides. So 2.25 minus 0.282, right? And I would get a mean of 1.968 is equal to the mean. So if we look specifically what the question's asking us here, what should the mean fill amount be set to the machine? So according to the normal model, all right, the mean fill amount should be set at 1.97 liters, so only 3% of bottles are overfilled. All right, so now if we continue on to part C, okay, it says customer complaints about underfilled bottles lead the machine to be set to a mean fill of about 2.15 liters. What does the standard deviation need to be in order for no more than 3% of bottles to be overfilled? Well, so now if we go to this one right here, right now I know that my mean is 2.15. I need to find out what my standard deviation should be. Okay. And I know that my z-score we just found the last time was 1.88, right? If we go back here, this z-score we just found last time was 1.88 for 3% above. I can use that same z-score value here, right? So now, again, if I'm going back to that formula, x equals z times the standard deviation plus the mean, right? An overfilled value is still 2.25. My z-score is 1.88. I don't know what my standard deviation needs to be, but I know that my mean is 2.15. So I could simply solve this out. Subtract 2.15 to both sides. 0.10 equals 1.88 times the standard deviation. Divide both sides by 1.88. All right, so if we divide that out there, 0.10 divided by 0.188, sorry, 0.10 divided by 1.88, and I get a standard deviation of 0.053. Okay? So now again, we want context. Okay, we want to write out our answer according to the normal model. If the mean is set at 2.15 liters, okay, the standard deviation must be 0.053 liters, so only 3% of bottles are overfilled. All right, I have context. I have my work done out so we can clearly see how we derive the answer. Okay, so this is the type of stuff you want to do on a free response question. Okay, you want the reader to know where your answer came from. Okay, and you want to make sure that your answer is in context, like we've talked about. Context, context, context. I hope that this quick video was helpful to go over parts B and C. I apologize we got cut off at the end of the class, but again, I hope this is helpful. I will see you guys all for our check-in 8:05 Friday morning. Have a great day.